It says find segment lengths in circles. Page 49, page 50 is what we're going to have. 49 and 50. Theorem 1014, segment chords theorem. What this says is for the segment lengths, it says the product of the length of the segments of one chord equals the product of another segment. So when you look at it, you look at AE times EB will equal the other side. Let me get a highlighter. So AE times EB will equal ED times EC. And you can find those segment lengths. Okay. On the next theorem, 1015, it says the segments of secants. Here we have secants that go through it. And with this setup, it says two segments share the same outside point. This is on the outside. It says the product of the lengths of one secant segment and its external segment equals the product of the length of the other segment and its external segment. So to stretch this out, you're going to do, it says here, EA, which is the outside, times the entire thing. It will equal EC, which is the outside, times this entire thing. So you'll have those particular problems, outside times the entire length, outside times the entire length, that will give you equal segments. Then on theorem 1016, this is dealing with a secant and a tangent this time. The secant will be the same pattern that you had on the previous one. You'll take the outside and multiply it times the entire length of your segment. But the tangent one, you're just going to square it, because the tangent is both the outside as well as the entire secant or the segment or chord that they actually have. So it's the product, the length of the secant segment and its external segment equals the square of the length of the tangent segment. There's your three cases and your formulas for each one, so make sure you have those written down so that you can reference them with their pictures and know what it is you're actually multiplying. Okay, if I turn my page, I'm going to do the first example. Put my example numbers on there. And on this one it tells us we're going to reference the 1014, because notice these two things are intersecting on the inside of my circle, so that means I'm going to multiply the segment lengths times each other. So it says we're going to find ILM and JK is my ultimate goal. So I'm going to take the little pieces. I'm going to check JN and multiply it times NK, so that's going to be X times X plus 5. And then the other segment, I'm going to take X plus 3 and multiply it times X plus 1. And here's some good old algebra practice. I'm going to distribute the X into the parentheses. That will be an X squared plus 5X will equal, and on the other side I have to FOIL this. That's X times X, which is X squared. Then I have X plus 1, or times 1, that would be 1X, and then plus 3X, and then 3 times 1 is 3. I need to combine like terms here in the center, so I'll have X squared plus 5X equals X squared plus 4X plus 3. I'm going to subtract my X squareds, and in doing so I notice they both cancel each other out. Okay, so the X squareds cancel out, so that gives you 5X is equal to 4X plus 3. I'm going to subtract 4X, and that gives you basically 1X equals 3, so that means X is equal to 3. So if I go back and plug it in, that would be 3 plus 3 means that this part is 6. And then down here on the bottom, that would be 3 plus 1. That means this little section here is a 4. So the entire length from N to M will be 6 plus 4. So that means ML is 10. If I go the other direction, that'll be 3 plus 5, which means this is 8. And that little section there is 3. So 8 plus 3 means that JK equals 11. Okay, on example 2, here I have two secants, and this is referencing that theorem 1015 with the two secants. Remember, it tells you we're going to take the outside secant, external secant, and multiply it times the entire length on both of those. So if I look at the outside, I have 6, and the entire length is 10. It's going to equal the other side. Here I have the external part is a 5 times the entire length, which here's my x, so this entire length is x plus 5. I'm looking for x on my problem. If I now multiply this gives me 60 is equal to, and distribute the 5 into the parentheses, that gives you 5x plus 25. This is now a two-step problem. I'm going to subtract the 25. I believe that is 35 now. And I'm going to divide by 5. That tells me x is equal to 7, and that solves my problem. On example 3, it says find the lengths of the, using this theorem, 1016. This is a tangent and a secant. With the tangent and the secant, it told me I'm going to square the tangent and then multiply the external times the entire segment. The tangent is my 14 right here. That's my 14. So I'm going to square my 14, and it's going to equal, and on this one the external is x, and I got to multiply it times the entire secant, that is x plus 12. Alright, if I work through this, I'm going to do 14 squared, which is 196, is equal to x squared plus 12x. I'm going to move the 196 to the right hand side. That will give me, that means I'm going to subtract it. That means I will have x squared plus 12x minus 196 equals 0. Okay, now this one poses a little bit of a problem because I need to put a 1 in front of the x squared, because this is of the form of ax squared plus bx plus c. And the reason I did this is so that we can see that a, and let me place this over here on the side because we got a major problem here. This is a equals 1, the b is equal to the 12, and the c is equal to, and notice it has a negative, so that means this is, the c is equal to negative 196. And the reason we've got to do this is this is not a factorable solution at all, so we have to use the quadratic formula that I don't know if your previous teacher taught you or not, so pay close attention to this quadratic formula. This formula, I'm going to write it right here on this side and then plug it all in so that you can see how it works. The actual formula, it's a big one, so pay attention. Whoops, and I just messed it up. I gotta concentrate here, make sure I get this correct. Okay. This is said x equals, that means that is our solution. It says the opposite of b plus or minus the square root b squared minus 4ac all divided by 2a. This b, a, and c I'm going to replace with these numbers. So, okay, Okay, I'm out of room, so I'm going to put a little postie on here and show you how to use this quadratic formula. And this is what this is called. I'll write that on there. Quadratic formula. So you can see this the way it's going to work. So I'll put it right beside it so you can see me plug it in. Okay. So this has an x equals, and this has a negative b. So b is 12, so that means negative 12 plus or minus, and then I have this square root, and it wants the b squared, so that means that's going to be 12 squared minus 4 times the a value, which is a 1, and then I got to multiply it times the c, which is negative 196. And I'm going to divide it all by 2 times a, which is 1. Now, I'm first going to place in my calculator with a plus sign. So I'm going to put, if I can get that on my calculator, negative 12 plus, and I'm going to do the square root, 12 squared minus 4 times 1 times negative 169 over 2 times 1. Okay, that's my first problem. I'm going to type that in and enter, and I come out with x equals 9.2. Then I'm going to type it in again. I'm going to enter, and this time it's going to be exactly the same, except for that little plus sign changes to a subtract sign. And then I'm going to enter, and I get x equals negative 21.2. Okay, if I look at my two answer choices, I need to look at my picture to make sure that they both are valid answers. And if I look at my picture, the x actually represents a length of a segment all by itself. So that means I cannot have this negative 21.2, because that means that length there would be a negative value. So I know this is not an option. My only answer is actually 9.2 for the length of that segment. I'm going to put that in the center, and then I'm going to glue this in so that I can actually see it in my notes. So, okay, flipping it over so you can do your independent practice. There's independent practice 1 that I want you to try to work. Here's number 2 you can work, and then number 3 as well I want you to work, and then start the program again and see if you get the correct answers. Okay, on number 1, this is intersecting inside, so that means I'm going to take my two pieces here, and I'm going to multiply them together. My two pieces there, and I'm going to multiply those guys together, so that I'm actually doing 5 times 12. It will equal 6 times x. 5 times 12 is 60. That's 6x divided by 6, and x equals 10. Okay, if I look at independent practice number 2, here I have two secants. I'm going to take the 7 and I'm going to multiply it times the entire length, which that entire length is x plus 7. And it will actually equal the other side. I want that external segment, which is 6. I'm going to multiply it times the entire length, and that entire length is 14. If I look at doing the math, I'm going to distribute and get 7x plus 49 is equal to, I think, 84. I'm going to subtract the 49. 84 minus 49 is 35. Divide by 7, and x is equal to 5. And now on number 3, 8 is the tangent, therefore I'm just going to square it. And it will equal the external, which is x, times the entire length. So that's going to be x times, and the entire length is x plus 6. And if I work this problem, that will be 64 is equal to x squared plus 6x. I'm going to move the 64 back over to the other side by subtracting. That'll give me x squared plus 6x minus 64 equals 0. Okay, filling this in, that means this will be my A, B will be a 6, and C will be a negative 64. So I'm going back to my formula. Opposite of B, plus or minus square root B squared minus 4AC, all divided by 2A. If I substitute in, that's going to be negative 6 plus or minus square root. The B is a 6, so it'll be 6 squared minus 4 times A, which is 1. The C is negative 64, and divide it by 2 times A. This will be my x values. Grab my calculator. I'm going to put it in as a fraction, so that's going to be negative 6 plus square root of 6, squared, and then minus 4 times 1 times negative 64, 2 times 1. So the first answer has x equals 5.5. And if I go back up and check to make sure, gotta do the subtract sign now, and see that it says x is negative 11.5. And I'm double checking this one, and notice right here kj is the external secant, and I can't have a negative length for that part, and it is it doesn't have a coefficient, so that means this one is out, and my only answer choice is 5.5 for JK. For your answer. Alright, if you got it correct, make sure you're giving yourself smiley faces and being proud that you made it through that problem.